Question. Two balls have approximately the same mass of about 0.17 kilograms, and in the figure, the white ball strikes the black ball that is initially at rest, such that it follows the path as shown. So the white ball strikes the black ball that was initially at rest, and after collision, they follow these path as indicated. The black one is moving at 1.5 meter per second at an angle of 60, but the white one is moving with some velocity v, which we do not know, at angle of 30 degree. So what is the speed of the cue ball after the collision? Of course, the momentum is conserved. So let's try to conserve the horizontal as well as the vertical momentum. So the white ball that was initially moving at 3 meter per second, and the black ball has a speed of 1.5 meter per second immediately after the collision, right? Okay. So initial momentum, if we talk about, and I'm talking about the x-axis, momentum towards the x direction. The initial momentum is, of course, the mass times velocity, which is only because of the white ball. So mass is 0.17, and the velocity is 3. So this will come out as 5.4 kilogram meter per second. I'm sorry, it's not 5.4. It's 17 times 3 is 51. So that's 0. Sorry, 5.1. 5.1. Uh, uh, Not 5.1. It will be 0.51 because it's 0.17. So 0.17 times 3 is 0.51. What is the final momentum? So for final momentum, we need to make some effort because this is not towards the x-axis. So for the black one, the horizontal component of the velocity is going to be 1.5 cos 60, and the vertical velocity is going to be 1.5 sine of 60. Likewise, for this one, horizontal is going to be v cos 30, and the vertical is going to be v sine of 30 degree. The final momentum is gonna be towards the horizontal side. Since the mass is same, so for white one, that's gonna be 0.17 times v cosine of 30 degree, and for the black one, that's gonna be 0.17 times 1.5 cos of 60 degree. Right. Now these two should be equal. So let me just simplify. 0.17 times cos of 30 degree, 0.17 times cos of 30 degree is going to be 0.15. So 0.15v plus 0.17 times 1.5 times cos of 60 degree. This is equal to 0.1275. This is the final momentum. So the initial and the final momentum are same, which means that I can say P final is P initial, which means that 0.15V plus 0.1275 is equal to 0.51 over here. So 0.51 minus this value over 0.15, that is equal to 2.55 meter per second. So that is the velocity of the cue ball after the collision. Now they are talking about what is the kinetic energy just before the collision and just after the collision. So that's something which we can easily find now. Just before the collision, that's going to be kinetic energy initial is only because of the cue ball. So that's half, mass is 0.17, and v is 3 because initially it was moving with 3 meter per second square. So the initial kinetic energy comes out as 0.17 times 9 over 2, which is 0.765, 0.765 joules. That is the initial kinetic energy. And if we talk about the final kinetic energy, then the final kinetic energy is going to be because of the cue ball and because of the black ball as well. So that's going to be half m and v square. So that v we already found as 2.55, and for the black one that's half m and v square. V is 1.5 over here, it's given, so that's 1.5 whole square. So this value comes out as 2.55 square times 0.17 over 2 plus zero point 0.5 times 0.17 times 1.5 square. So this value is coming as 0.744 joules, right? It is a bit less than the initial kinetic energy. and which is part D, which is asking that what type of collision it is by finding the percentage change in the kinetic energy. So per percentage change, if we want to find, is nothing but the final value, which is 0.744, minus initial value, which is 0.765, over the initial value, which is 0.765 times 100. So this value comes out as, let me just grab my calculator, minus 0.765 over 0.765 times 100. So this is coming as negative 2.75 percentage. And negative means it's a decrease, right? And hence this is an inelastic collision. It is not perfectly inelastic because the objects are not stick together. It is just an inelastic collision because the kinetic energy is not conserved. If it was conserved, it would have been elastic collision.